life, people, and one question to drive it: why? We look out into space for answers, but we just find spheres orbiting spheres. We look inside ourselves for answers, but we still find spheres orbiting spheres. Coincidence? Think about it. Look at this peanut. Doesn't it look strangely like an 8? And if you turn it a bit, what do you get? Infinity.
Kids, stop playing around. We're trying to make a documentary.
Sorry.
And now, to introduce our topic. Our topic is a transfer of energy from forms of electromagnetic radiation to electricity.
Like matter, energy cannot be created or destroyed. So, then how do you explain something like solar panels seemingly pulling electricity from nowhere?
Well, the power that solar panels produce actually comes from the core of the sun. Wait, I just realized we forgot the title. Quick, someone put it in!
We can turn all kinds of energy into other types of energy, including light. The most common way that we make electricity into light is with light bulbs. There are 3 main kinds of light bulbs:
Incandescent,
Fluorescent,
and LEDs. Each of them transfer electricity to light in different ways.
Incandescent lights work by heating a thin wire in a glass bulb in a glass bulb full of a gas that prevents the wire from burning through, which would cut the current. What happens is the wire gets so hot that it starts to glow very, very, very brightly. But this is very, very inefficient, as only about 1% of the total energy gets made into light.
Fluorescent light bulbs send electricity through an ionized gas to make light. Fluorescent light bulbs are more efficient because they use less of their energy on heat and therefore are able to make an equivalent amount of light from less energy.
LEDs are made from 2 layers of material put together to make a type of diode. P-type semiconductor material is a material that's made from silicon and boron that, when combined, give the material positive carriers called holes. N-type material is the same thing but contains negative carriers instead and is made with different materials. These are both combined to create a type of diode. When a current is put through this diode, the electrons combine with the holes. The electrons have a lower energy level than the holes, so the remainder of the energy that gets released when they combine turns into light. And that's how LEDs work. There are also ways of doing the opposite and turning light into other types of energy.
The main way that light, or any other electromagnetic radiation for that matter, is converted to electricity is by photovoltaic cells. Photovoltaic cells work actually kind of similarly to LEDs, except in reverse. They, like LEDs, have 2 layers of usually silicon, P-type and N-type. Just the light is used as the power source, knocking the electrons from one to the other to generate kind of an electric pressure. And then this travels to sheets of conductive material underneath the panels to collect the electrons and concentrate the charge.
But aren't there more than one kind of photovoltaic cell?
Yes, but they all work on pretty much the same concept.
What about ways to make electricity from light that are completely different?
Oh, you mean like using sunlight to heat water and then using a thermal to electricity converter to make electricity?
Yes, that is one example, and one of the more common ones.
So, to recap what has been said, to convert electricity to light, you can use light bulbs, LEDs, fluorescent light bulbs, and incandescent light bulbs. And to convert light to electricity, you use voltaic cells, pretty much an LED diode working in reverse. That's all for today. The end.